Okay, guys, in the conics unit, why do you think we started with circles? They're easy. Why do you think we end with parabolas? They're harder, but you guys have had so much Algebra 2 under your belts, you can handle more. If you think about it, like the hyperbolas, once you covered ellipses, hyperbolas were not that bad. I mean, if you think about it, you know, from a formula standpoint, that's the equation of a what? That's an ellipse. And then that's the equation of a what? Hyperbola. The only thing different was the minus sign. So even though it looks radically different when you graph it, the center is still HK. The horizontal distance is A. The vertical distance is B. So even though there was a big shift in what the graphs looked like and more complexity, from a formula standpoint, there wasn't much change. So you've got that under your belt. Last semester, when we met our friends the parabolas, we had them in 3 different forms. There was a vertex form. Why do we call that the vertex form? You can look at that and tell that the vertex is what? HK, okay? We had another form called the intercept form because you can look at that and tell what? The x-intercepts are what? P0 and Q0. Then we had standard form. You could look at standard form and you could tell the y-intercept. The y-intercept was what? 0C was the y-intercept, and you knew that the axis of symmetry was what? Negative B over 2A. Okay, those are things we learned last semester leading up until Christmas. Okay, now what we're going to do, let's take a look, revisiting our conic sections. We talked about the first one. If you take you've got a right cone here, you take a slice that goes horizontally to the plane, that creates a circle. You tilt it and go all the way through, that creates your ellipse. Okay, so it goes through both sides. If you have a vertical that goes straight through both naps of the cone, then that creates your hyperbola. This is a vertical hyperbola. If you go through, instead of going all the way through both sides, if you go through this way, what you see here at the angle, this creates your parabola, okay, which is the one we're studying now. So this is the 4th of our conic sections. Now, this should be easy because they're spoon-fed to you in an order that makes sense in terms of what we covered, but the sum of, really it's not the sum. I've got some bad English going on here. The distance from the center is constant. That describes what? That's a circle, okay? So it's the distance from one fixed point. That's our description of a circle. The sum of the distance from, don't tell the English teacher that I wrote from between. The sum of the distance from 2 fixed points in the graph is constant. That is a what? That is an ellipse. I've got 2 fixed points. If I add the distance from the curve to each of those points, that is an ellipse. Pardon me? So like this is, what was our circle? It was what? X minus h squared plus y minus k squared equal what? R squared. That's a circle. It equals, so R is the radius, okay? The ellipse was what? X minus h squared over a squared plus y minus k squared over b squared equal 1. What makes that horizontal? A is bigger. What makes it vertical? B is bigger, okay? The difference of the distance between 2 fixed points in the graph is constant. What is that? That's the hyperbola. And the only difference between that and an ellipse is it can be, it's x minus h squared over a squared minus y minus k squared over b squared equal 1, okay? That was one way, and the other way is the y sign is, the y is positive. So these were our two forms of the hyperbola. Which of those is the horizontal? Yeah, the top one. This is horizontal. This is vertical. So you look at whoever gets the positive. Whoever gets the positive value, that's going to be the direction of horizontal, vertical. Now, the set of all points, and this is a little bit complicated definition, equidistant from a particular point, a fixed point, called a focus, to a particular line, we're going to call a directrix, that is perpendicular to the axis of symmetry. This is, what do you want to guess this one is? See, you guys are on top of it. This is a parabola. This is one of those that when I describe this, it makes absolutely no sense. The equidistance from a focus to the curve to a line perpendicular to the axis of symmetry, called a directrix. That's hard to visualize. So we're going to visualize that now. What I want you to do, you're not going to be tested on this, but this is just a visual. I want you to see exactly how this gets put together. So just follow with me as we go along here. I'm not going to save it. Let's create a new graph. Okay. So we're going to use the geometry to construct a parabola. So let's create a point. So I'm going to create a point, and I'm trying to make this about 2, 4. Put it in a certain spot, and we'll call this point F. And what I'm going to do is I'm going to not label it, but I want to find the coordinates of that point. So let's just say menu and actions. Let's find the coordinates of this point. So this point is, I want to make it 2, 4. So what I'm going to do is just go in and physically make that 2, 4. Okay, so I've moved this to the point 2, 4. This is going to be my focus. Okay, now I'm going to create a line. I'm going to create a line at y = 2. Okay, so I've got a line and I have a point. And what I need to do, that's a line that's been graphed, but I need to make a line from the geometry section of the calculator. So let's create a line that has a point here and a point over here. So I've got my line in place. Okay? So far, so good. Now, let's just pick a point somewhere on this line. So I want something called a point on. Let's pick a point on this line. Okay, so now I have a point on this line. Let's label this point, call it point Q. Okay. So I've got a point, which is the focus, and I've got a point on the line. So what the parabola tells me is the distance from here to the parabola and from the parabola to this line have to be the same. That's the definition of the parabola. So we're going to construct it with geometry. So let's create a line segment that connects point F and point Q. Okay, everyone agree that's the line segment creating F and Q. Somebody tell me, what is a perpendicular bisector? Pretend like you had geometry last year. So what does perpendicular mean? Cross at what kind of angle? 90 degrees. What does bisector mean? To bisect something. You cut it in half. So a perpendicular bisector will be a perpendicular line that cuts that in what? Cuts that in half. So let's create a perpendicular bisector. So create a perpendicular bisector of this line. Okay. Now, something is askew with the smartboard. Does that look perpendicular to you? It doesn't, but I don't know if you can see it on my screen. It looks perfect. That's just sort of the teacher thing. It looks perfect to me. So suspend your disbelief and just trust me that this is a perpendicular bisector. Something is off in I think the scaling of the smartboard, that it's handled correctly over here. But if this were, I wish I could just draw like the little box here so you can see that that's perpendicular. Because you probably learned last year, never assume when you look at something unless that is there, right? But now we're not assuming, but I'm telling you, that's a perpendicular bisector. So according to the parabola, it's going to be the equidistance from this focus to some point and then direct down to the perpendicular to this line. It's going to be constant. So I need to create a perpendicular line So let's create a perpendicular to this line at this point, okay? And now let's go find where these 2 points intersect. So I can find that. Let's find the intersection of this line, and we're going to label that point Z, okay? See if I can move that around. There we go. So I've got a point, and I've got a focus, and I've got a line. Now what I want to do, let's just create another line segment. So let's create a line segment that completes this triangle that goes from point F to point Z. Okay. Now, somebody tell me what figure do I have here? What is FQZ? It's what? It's a triangle. Now, but how many triangles do you see? You see 2 triangles. There's the triangle here, from here, here, and here to here. Okay. You're seeing, I see here's a triangle, here's a triangle. Oh yeah, 3 triangles. Now, what do I know? According to the formula of a parabola, this distance FZ and ZQ have to be equal. Do I know that geometrically? Can you reason that those are equal? You can't look, you got to look at what you know. So first of all, what about these 2 triangles? Do I know anything about these 2 triangles? They what? Yeah, so I know that they share one side, right? So that side is what in both triangles? It's equal, okay? I know that side is the same. What about this angle here and here? Those are the same, right? What about this side from here to here and here to here? How do I know those are the same? What was the definition of this line? It's a what? Perpendicular bisector. What does a perpendicular bisector do to this line segment? Cuts it in half. So I know that so how do I know these 2 triangles are congruent? How do I know it? What kind of congruency is it? Do I need to go across the hall and get one of these geometry teachers to come over here? How do you know triangles are congruent? There are different ways you knew triangles are congruent. There it is. You guys listen to Natalie. It's side angle, side. This side, this angle, this side. This side, this angle, this side. Side angle, side. Congruency. So, if these 2 triangles are the same, what do you know about this distance and this distance? They're the same, okay? So, I've constructed it where you know that this distance from here to here and this from here to here has to be equal. Now, this is what I find a little bit fascinating. We'll see how it works with you guys. I'm going to move point Q left and right, okay? I'm just going to drag it left and right, and that triangle is going to move. And tell me what you see happening. What is it drawing? A bigger triangle, but look at point Z. What is point Z doing? It's drawing a parabola. There we go. So I find it amazing that by fixing one point of the triangle, and just moving this other point, the triangle is drawing a parabola. So by moving just one point left and right, this triangle draws a parabola. Now there's something called a locus, which just is a fancy word for trace those points for me. So that's what we were doing. So from point Z to point Q, if I move this, you see what it's drawing. It's drawing a parabola. So no matter how much I move point Q, it creates a different, it's creating isosceles triangles all the time. In each isosceles triangle, it gets bigger, smaller, rotates, moves. That's my parabola. So what was this point of the parabola? We learned this last semester. This is the what? Let's go with vertex. This is new. This is the focus. And this line right here, the line that's perpendicular to the axis, this is called my directrix. Okay, so this is our terminology. We've got a focus, a vertex, and a directrix. And then the definition of the parabola, the distance from the focus to the graph to the line that's perpendicular to the axis of symmetry, those are all constant. Okay, Now, let's take it back over here. So, definition, what we just saw there. We saw a curve, and what you've got is, here's your focus. The distance from the focus to the curve and the curve to the directrix, those things are always equal. So if you were to go way up here, so for example, if you were to go from the focus up to here on the curve, then that line down here, these things have to be equal, okay? So that's just sort of the geometric look, and this is more complicated geometrically than what we've seen with circles and ellipses. But I'm not going to test you over what just happened on the calculator. It was just sort of to set the ground. But come on, it's got to be interesting, okay? So, you could too. You could too, you know? Yeah. Okay. Now, last semester, these were the parabolas we studied. They could open up or they could open down. What was your key to them opening up or down? Yeah, the coefficient. The coefficient is positive, you're in this situation. Coefficient is negative, you're in this situation right here. Now what's going to happen is our parabolas, besides just opening up and down, they could open left or right. So this is a parabola opening to the right, parabola opening to the left. What's the difference between these two formulas? Yeah, you just switch the x minus h and the y minus k. This says that for every y, you have two x's. So pick a y value. So if this is my y value, I've got x1 and x2. There are two x's for every y. This one says for every x, there are two y values. Pick an x value. You get y1 and y2. Okay? So if the coefficient is positive, it's going to open to the right. If the coefficient is negative, it's going to open to the left. Okay? So the vertex, looking at this, what do you expect the vertex to be? HK, just like it was for a circle, an ellipse, a parabola, except it's not called a center, it's called the what? Vertex here. Okay, so the vertex is HK in this particular form. What was this line that we drew right here? What was that called? Axis of symmetry. Axis of symmetry always goes through the what? The vertex. So if the axis of symmetry goes through the vertex, it has to be x equal h. Okay? So it's a vertical line going through the x coordinate of the vertex. Here, your axis of symmetry is what kind of line? Horizontal. It still has to go through the vertex. So it's the line y equal k. It goes through the y value of the vertex. Okay? Now, this other thing, I wrote it this 1 over 4p. The coefficient of the parabola is going to be 1 over 4p. The reason I write it that way, that's standard conic form. If I write it that way, p is the focal distance. Now, in all of our other formulas for ellipses and hyperbolas, we use the letter c for focal distance. Here, p is the focal distance. So it is the distance from, if you look at a vertex, the distance from the vertex to the focus, that is p. The distance from the vertex to the directrix, that is also p. Okay? So p is the focal distance, the distance from the vertex to the focus, and vertex to the directrix. So in this case, p is the focal point. So the vertical distance from p to the vertex, here p is the horizontal distance from p to the vertex, and the directrix. In this case, your directrix in this case is going to be a horizontal line right here. So you've got a focus, and then you got a directrix. Here you're going to have a directrix and a focus right here. Okay, so the distance is from here to here is p, from here to here is p. Here your directrix is going to be a vertical line and a vertical line. Okay, so let's just take a look at some examples. Overwhelmed there, Kyle? So let's look at this. There are two forms for the parabola. So this one is going to be the form y minus k equal 1 over 4p x minus h squared. I write it in that form because the y term is linear, the x term is quadratic. So I'm going to use this form. The other choice would have been x minus h equal 1 over 4p y minus k squared. And you can see that's not going to work here. Okay, I don't have any y squareds. So this cannot be the form. It has to be this one. Okay, so it's, yeah, Kyle said this is what, vertical, horizontal? This is vertical. Does it open up or down? It opens up because the coefficient is positive. Okay, so this is a parabola that opens up because of the positive coefficient. No, the 1/8. Here's my the coefficient of the x term. So this is positive, so that means it opens up. Okay. Now, what is the vertex? Yeah, -1, 2. Why are you wrong if you say 2, -1? That's your y and x. So you don't just look at this and say it's this. That you have to look, where's your x? It's -1 and 2 is the vertex.
So vertex equals center.
Well, no, not center.
You know what I mean.
You can say that, but don't do it on a test, you know. So, yeah, in all of the other forms, HK meant center. Here, HK doesn't mean center. There's not the center of a vertex. A vertex doesn't have a center in it. Excuse me, a parabola doesn't have a center. It only has a vertex. Okay, so at this point, I know that this is the vertex of my parabola. Okay. Now, let's figure out what this value of P is. Okay, so I've got 1 over 4P. That's going to have to equal 1/8, okay, to put it in this formula. So let's figure out. Look at you guys. You said you're not a math person. Look at you over there. What does P have to be for that to be true? 2. P is equal to 2. So P is the focal distance. So that means that if this thing is opening vertically, I go up 2 and I go down 2. And there are two things of consequence happening. Now, this parabola, does it open up or down? It opens up. So which one of these is the focus? Yeah, that's the focus. And this is the directrix. And this parabola does this. Now notice I haven't had to pick points. I haven't had to substitute values in. Okay, so P was equal to 2, right? So the distance from here to here is 2, okay? And then the distance from here to here, that also equals 2. Okay? Because P, the focal distance, is 2, the distance from the vertex to the focus is 2, and from the vertex to the directrix is 2. So once you figure out that P is 2, from the vertex you go up and down 2. One of those is the line, and one of those is the focus point. Because this opens up, this has to be my focal point. Now, axis of symmetry is this line right here. Okay. So that's my axis of symmetry, and this is my directrix. So what is the equation of the axis of symmetry? X equal, but in this one it's X what number? X equal -1. So axis of symmetry, X equal -1. What is? It's right here at -1. Where X is -1 everywhere on this line. This is the line. This is the line. That's the line X equal -1. What's the equation of the directrix? Y equal, not 2, 0. Y equals 0, okay? So the directrix is the line Y equals 0. What is the focus?
Is the directrix always 0?
No.
Would it not be 0?
Well, if this parabola, if the vertex was here and the directrix was here.
So the directrix always is the bottom.
Well, not if it opens downward. Stick with us, stick with us. What's the focus? What's the focus here? -1, 4. Okay. Okay, guys, lots of moving parts here, but you got to know this formula. This formula is a little bit different than what we did in the fall. This is standard conic form. That's why you have that 1 over 4p, because if I write it 1 over 4p, p is going to tell me what the focus is, okay? So it makes it a little bit easier. Let's move on to another one. Now, this one uses a different form. Why is this one different? Yeah. Yeah, it's horizontal because the y is being squared. So this formula is x minus h equal 1 over 4p y minus k squared. Okay? That's the form that I need to use for this one. Now, is this vertical or horizontal? Yeah, this one is horizontal. For every x, there are 2 different y values. Okay, so that means it's either going to look like this or like this. Okay. So which one is it? It opens where? Yeah, this opens to the left because it has a negative in front of it. Okay. So where is the vertex? 2, 2, negative 1. So 2, negative 1. Okay. Now let's figure out what p is. To figure out what p is, I've got to set this equal to what? It's going to be negative 1. So I've got 1 over 4p equal negative 1/4. You can just cross multiply if you need to. That's 4 equal negative 4p. So p is equal to negative 1. So p is negative 1 means it's going to open to the negative direction. But when I look at this, if I go 1 in this direction and 1 in this direction, one of those is my focus and one of those is my directrix. What is this point right here? What is this one?
That's your focus.
This is the focus, and that's the directrix. So there we go. Okay. And then what's this line right here? That's the one. Yeah, that's the axis of symmetry. Okay, see? So this is the parabola at this point. Okay? This is the directrix. And then this line is the axis of symmetry. Okay? So P is negative 1. So what is the focus? What is the focal point? Yeah, 1, negative 1. What is the equation of the axis of symmetry? Yeah, y equals what? Well, but yeah, negative 1. It's a y equals, and it's whatever the y value of the vertex is. And what's the equation of the axis of symmetry? Oh, sorry, I did that. Y equals negative. What's the equation of the directrix? Yeah, x equal 3. Okay? So what you want to do is plot the vertex. You plot the vertex. Once you get the vertex, set 1 over 4p equal to the leading coefficient. That's going to tell you what p is. By definition, p is the distance from the vertex to the focus and the vertex to the directrix. Then you're able to look and say, okay, when you plot those 2 points, figure out which one's the directrix. Now, guys, how would this be different? How would this problem be different if this were positive? What would that change? Yeah, this would be the what? Focus, and this would be the. Yeah, that's all that would change. So all that would change there in that case is just it would flip. Okay, the focal distance stays the same, the vertex stays the same. It's just the directrix and the focus switch roles. So this is our summary. You've got 2 different forms. This is what a horizontal parabola looks like. You've got a linear term for x, quadratic term for y. And then this will open to the right if p is positive, open to the left if p is negative. Okay? So for an example, if you were to look at this is a horizontal parabola opening to the right because this is positive, the vertex is 4, negative 2. This one has a negative coefficient. This opens to the left. The vertex is 0, negative 7. Okay. The ones that open up and down, you guys are experts with those because we did them last semester. Y minus k is 1 over 4p x minus h squared. You have a linear term, quadratic term, and it opens above if p is positive. So in this case, you've got a vertex of negative 1, 0. And here this opens down. Your vertex is negative 2, negative 7. Okay. So I think we have one or two more. Two more and we're done. Okay. So tell me about this one. What form of the equation do I need to write? This is what? Y minus k equal 1 over 4p x minus h squared. So what is the direction of open? Is this vertical or horizontal? It's vertical. Open up or down? Opens down. Okay. What's the vertex? Yeah, 3, negative 1. Okay, so 3, negative 1 is right here. Okay. Now let's figure out what p is. So if 1 over 4p equal negative 1/8, what is p? Yeah. P is negative 2. If you can't do that mentally in your head, just cross multiply. 8 equal negative 4p. Then you know that p has to equal negative 2. So I use that p value to pick 2 points that are, this one's opening what, up and down? So I go up 2 and down 2. Okay. Which way did we say this thing was opening? Down. So I know that it has to look like this. That makes this the focus and this the what? Directrix. Okay. So I've got that. Axis of symmetry always goes right through this parabola. Okay. What's the equation for the axis of symmetry?
X equals 3.
Yeah, x equals 3. What's the equation of the directrix? Yeah. And what is the focus? Yeah, 3, negative 3. Okay. So pretty straightforward. But like I said, you got to be solid with the formulas. Which ones open up and down, which ones open left and right, how to tell if it's up or down, left and right, and which formula to use. So I think once you get that part, it pretty much starts to follow. Yeah. Okay. What about this one? What's the formula? Yeah, x minus h.
That's probably the hard part.
Yeah, y minus k squared. Okay. Which way does this guy open? Is this horizontal or vertical? This is horizontal. Which way does it open? It's going to open to the right. If it's horizontal, to the right. Okay, what's the vertex? Yeah, 4, negative 2. So let's graph that. 4, negative 2 is right here. Okay, let's figure out what p is. Is this too fast?
Yes. Very fast.
Am I going too fast today?
PS4, by the way. I just wanted to slip you up. Yeah, PS4.
You tell me to slow down and then you say PS4. You're just trying to, you make me slow down so you can get the right answer. You're just trying to make yourself look good. So p is equal to 4. Okay. So we've established this is this horizontal or vertical? Horizontal. So what do I do with that p equal 4? I go 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Okay. Which way is this guy opening? So that means if it opens to the right, like this, that's the focus. This is the directrix. And where's the axis of symmetry is right here. Okay. So what's the equation of the axis of symmetry? Yeah. Y equals negative 2. The directrix is x equals 0. And what is the focus point? Yeah, 8, -2. Okay. And that is it. Okay. So guys, you just want to be solid with the formula and know which ones opens horizontal versus vertical. Figure out how you got to remember that, and then I think they pretty much fall from there. Sure.